Hello dear friends, in this video I'm gonna explain you the first law of thermodynamics. So let's revise some definitions from the past. So what is internal energy? So internal energy is a total kinetic energy of all gas molecules. So what is average kinetic energy? So the average kinetic energy depends on the temperature of the ideal gas. So the first law of thermodynamics, it is the law for heat engines. So what is a heat engine? Let's watch from this video.
But he was never able to make it at the time. He hadn't got enough materials of the right sort to be able to create the effect. So this one though is going to work for us. We've now advanced a lot of material science in the last 125 years, and this is going to get it's going to heat up the tube here. We're going to get a temperature difference across the tube. There's a piston inside which you can just about see coming in and out of that metal plinth when it comes around to the outside there. A little black piston appears and disappears. It's attached to a flywheel, and once we give it a kick start, a bit like starting a car, it's going to revolve at a very fixed speed of about 2,700 RPM. There we go. There she blows, first time. So this will revolve for as long as there's fuel in here. There's a little bit of meth spirit in there. And as long as it's providing heat to create this standing wave, the heat differential will make the motor.
So heat engines, just by simple words, they take heat to do work. So they use thermal energy to do a mechanical work. So in this case, thermal energy is transformed into mechanical work. So what happens in this video is gas is heated. It means that thermal energy is given. So thermal energy is used to rotate the shaft. So this is mechanical work. It's denoted by letter D. So in between we have gas. The temperature of gas is increasing. The internal energy of the gas is increasing as well. So here we have three letters: Q, delta U, and W. So and this brings us to the first law of thermodynamics, which is the law of conservation of energy for thermal processes. So this is the formula that we're gonna work on in this video. So Q is heat added to the system, W is work done by the system, and delta U, it is the change in internal energy of the gas. So this is the simplest illustration of this process. So here the candle is giving the heat to the system in order to push this piston up. Okay, when the piston moves up, it is the work done by the system. And here also the internal energy of gas is increasing. Why? Because the temperature of the gas is increasing. So the energy can be positive or negative. In this case, let's consider each term when they have plus sign or minus sign. So heat will have plus sign when heat is added or absorbed, and minus sign when it is released or taken out. The work done will have plus sign when the work is done by the gas, and minus sign when the work is done on the gas. Change in internal energy will be positive when the temperature is increasing, or minus sign when the temperature is decreasing. So if we solve this question, so here we have to pay attention to the words. A system does 300 joules of work, so it means W is equal to 300 joules. So it absorbs 800 joules of heat. It means Q is equal to 800 joules. So So delta U is unknown. Let's write the formula. Q is equal to delta U plus W. If we substitute the numbers, Q is equal to 800, which is equal to delta U is unknown, plus W, which is equal to 300. So here delta U is equal to 500 joules. This is a fairly easy problem. Now let's move on to the next problem. So here in this problem, 640 joules of work is done on a gas. So it means that work in this case will have minus sign, and 200 joules of heat is released. So it means here Q is also minus. So delta U is unknown. So if we write the formula, Q is equal to delta U plus W. If we substitute the numbers, Q is minus 200 equals delta U minus 640. Delta U is equal to minus 200 plus 640. So the delta U is equal to 440 joules. So thank you for your attention. I wish you luck.